Okay, here we are, chapter 5.6, dividing decimals. This is decimals divided by decimals. So this is something we need to talk about. We need to understand what we're doing here. For instance, they might have, two decimals like 0.6 divided by 0.3, and we need to understand what to do with that. So I'm going to show you an example, and then we'll come back to this one. Okay. For instance, if we do 10 divided by 5, the answer is 2. Whoops, not 20, it's 2. All right, and if we were to multiply 10 by 10 and multiply 5 by 10, when I multiply by 10, I just move the decimal over, or it gets 10 times bigger. All right, so 10 times 10 is 100 divided by 5 times 10 is 50. And we can see that 100 divided by 50 is equal to 2. And if I were to multiply 100 by 10, 100 times 10 divided by 50 times 10, oops, not divided by 10. Let's fix that. Make sure it looks right. 50 times 10. Okay, this looks like 100 times 10 is 1,000. Divided by 50 times 10 is 500. And 1,000 divided by 500 equals 2. See, 2 times 500 is 1,000. 2 times 50 is 100. And 2 times 5 is 10. All right, so what we're noticing here is that I can increase or decrease, actually, and get the same answer as long as I use multiples of 10 and I do it to both. Okay, so in the textbook it says when you multiply both the divisor and the dividend by the same power of 10, the quotient stays the same. Remember, the quotient is our answer to a division problem. Okay, now if I were to change this up, let's see if I can find the same color, and do 1 divided by 0.5. So basically I divided this by 10, so this is 10 times smaller. 10 times smaller than 10 is 1, and 10 times smaller than 5 is 0.5. This would be equal to 2 also. 2 times 0.5 is 1. So what you're supposed to get out of this is that when you get a decimal that's divided by a decimal, you can multiply by powers of 10 to move that decimal over one place, and move this decimal over one place too, so that it becomes 6 divided by 3 equals 2. Now it might be just a coincidence that our quotient has been 2 on everything on this page. In fact, I think it is a coincidence because I didn't really plan this problem out to surprise you with this magic number 2. But it is working, and I want you to make sure you understand how to do this, and I'm going to show you more than one way to do it because it depends on whether our problems look like something like this: 0.72 divided by 8. Oops, not 8. 0.08, or it could be that our problems could be rewritten like this, like 0.7 into 5.6. Okay, so whether we write a traditional division problem or if we write the long division format of a division problem. Now remember that this is the same as 5.6 divided by 0.7. This one is, when you read it, you say 5.6 divided by 0.7. This one, when you read it, you say 0.7 goes into 5.6, and we say how many times. All right, so we're just going to start moving decimals because that's what this is all about. If I multiply this, I want to move this decimal 2 times, and I want to move this decimal 2 times. Okay. It's nice that they're both the same, but they don't have to be. Okay, I could just I have to move the decimal the same amount, but let me show you in a little bit how this could come out a little differently and still get us a good answer. Okay, so this becomes, when I move it 2 times, that means I have to multiply it by 2 powers of 10. So that's like times 10 times 10, or really times 100 times 100. So I multiply 0.8 times 100, and I get 8. I multiply 0.72 times 10 times 10, which is the same as 100. I get 72. 72 divided by 8 is an easy one. I know the answer to that. It's 9. And because 72 divided by 8 is 9, 0.72 divided by 0.08 is also 9. Okay? Now, this one, we're going to move the decimal as well. This time it only needs to be moved one place. And we're still going to multiply by 10, or we're going to multiply by 10 to the first power. Okay, it just depends on, we could have written this one as 10 to the second power, and we just need to make sure we understand that 10 to the second power is 100. It's 2 powers of 10. So this one becomes 7 goes into 56, and 7 times 8 is 56. So the quotient is 8, okay, and the quotient over here is 9. Either way, it works out. We just have to move the decimal and move them the same amount in both the dividend and the divisor. Okay, so the dividend is this one, the second one that's inside, and the divisor is what's divided by 7 goes into, or 0.7 goes into 5.6. This is the dividend, this is the divisor. On this one, it's the other way around. This is the dividend, and this one is the divisor. So this one is the divisor, and this one is the dividend. It's important for us to keep track of these because they look like they're on the opposite sides, and we just have to kind of understand that 5.6 divided by 0.7 gets turned into 0.7 goes into 5.6, and they get switched, but they are still what they are. We still have divided by. The divisor is what's divided by, and the dividend is what's being cut up into smaller pieces. Okay, so real quick, I'm going to show you just one or two, grab a couple from the book. I wanted to see if they do something where they're different. They do. They throw in, let's see, they kind of keep it the same. Yeah, it looks like they do pretty much most of the time, except for this one, 1.26 divided by 2.1. Now, in this case, I'm going to turn it and we'll do it both ways. This is 2.1 goes into 1.26. Now, if I were doing long division here, I would multiply by 10. This is the long division side, and the decimal would move over one place. And see, it's okay if it just moves over one place in this problem. Then we get 21 goes into 12.6. Now, this is still a decimal problem, but we know how to do this. All right, all we do is we put the decimal up on top, and then we say, well, how many times does 21 go into 12? Well, it doesn't, so 0. And then we kind of have to estimate or guesstimate how many times 21 goes into 126. And I'm guessing it's going to be 6 times. 2 times 6 is 12. So we're going to put a 6 here. 6 times 1 is 6. It's looking pretty good. 6 times 2 is 12. And then when I subtract, I get 0. So there's 0 remainder. So the dividend, or so the quotient is 0.6, 0 and 6 tenths. Okay, so if I cut 1.26 and I divide it by 2.1, see, now this is odd because this is actually a bigger number than this. So we have a bigger number dividing a smaller number, and that gives us an even smaller number. It's kind of an odd way to do it, but it's something we need to pay attention to. Okay, so the same thing over here. We're just going to move it one place. We could move it 2, but then we'd have to, we'd add another 0, and instead of this being 21, it would be 210. So we're still just going to multiply by 10. Okay, just because. So it's 12.6 divided by 21, and this isn't one we could do in our head. Even if we multiplied it by another 10, so that it becomes 126 divided by 210. We still can't really divide this very well without our long division method. Our long division method is the best way to do it. A lot of times we can do them in our head. This time we have to be able to use long division. Let me show you how you can sometimes do it in your head. 0.24 divided by 0.4. Okay, so if we move this over one time and this over one time, we've got multiply by 10. Then, see, 4 goes into 24. I can kind of work that out in my head. But we're still going to move it over. 2.4 divided by 4. Now, this is, even though they're both, this is still a decimal, 2.4, and over here we had 2 decimals, now we're down to 1. I could probably figure out that 8 times 4 is 24. So if I have to get 2.4 by multiplying, and this is by going backwards. 8 times 4 equals 24. This is moving backwards. 24, 2.4 divided by 4 is 8. I have to add, to make this really work, I've got to go 0.8. Okay. Now I could do long division. I could say 4 goes into 2.4. And what I want you to understand is that if you're doing long division, it works a lot better if you get rid of the decimal here, but you don't have to get rid of the decimal here. So when we moved this decimal one place and we moved this decimal one place, it got rid of the 4 in the divisor. Okay, it's okay if the 4 in the dividend is, or if the decimal is still in the dividend, but we got rid of the decimal in the divisor. Okay, I started to make a mistake there with what I was saying. Hopefully you guys understood. So we just put the decimal up and we do long division. Even if we're not sure we want to do this in our head, 0.8, we can just do long division. 4 goes into 2. No, it doesn't. See, and then I have a decimal here, and then I forget that there's a decimal here, and I think, how many times does 4 go into 24? Well, it's not 8. Look at that. Some of you guys have been screaming for 5 minutes because I wrote an 8 and it's a 6. And this is a 6 too. Let me actually grab my eraser on this one. I don't think that's the real eraser. There we go. Whew, that was such a close one. I almost made a ghastly mistake. 0.6, because 6 times 4 is 24. 0.6 times 4 is 2.4. So that's going to work out. Anyway, it's 0.6. This one is 0.6. You can see if you multiply back, 6 times 4 is 24. Okay, so giant mistake. Sorry about that, guys. I'm glad you caught it. You can all tell me about it in school tomorrow. Okay, talk to you later.